You are welcome, dear Professor Dr. Dave Stahle. The Professor Dave comes from University of Arkansas, from United States. About his biography, the Professor Dave Stahle is a distinguished professor at the University of Arkansas in United States. He earned his PhD in physical geography from Arizona State University in 1990 and was elected a Fellow of the American Association for the Advancement of Science in 2015. His research focuses on touring chronology from the United States and Latin America, reconstructing past climate and analyzing their social and environmental impacts. The Dr. Stahle has also contributed to the conservation of ancient forests in United States and Mexico through mapping and protection efforts. The topic that he will give us in this Ecuadendro 2025 conference related with the following. Touring and historical perspective on recent at Amazon River Live Stream. So you are welcome to start for this in this conference. There are Professor Stahle.
Thank you. Let's see if I can share
start.
my screen.
Yes.
I hope you can see this. Oops. Can you see my screen, Kelly?
In that moment, not yet.
Not yet. Oh, great.
Yes.
Well, Zoom wants me to update some stuff. Let's see. Try again. Privacy and security.
Okay. How I have your presentation, I could share you. If you
1 second. Let's see if I can get this going. How about that?
okay, we are starting to see your presentation.
Okay, swell. Yeah, sorry about that. Let's get this going. Can you
Yes.
see it?
This is
Okay.
ready now.
Okay. Thank you so much. Well,
Okay.
appreciate you having me and inviting me to this first Ecuadendro session. And I am speaking on behalf of myself, of course, and Daniela Granada de Souza. And I'd like to thank you all for speaking in English, because it's easy for me, but I know it's not so easy for everyone else.
Yes.
I had never intended to go to Brazil. I had never intended to work in the Amazon. I do not speak Portuguese, but there was an Inter-American Institute for Global Change Research Conference field week for dendrochronology in southern Brazil, where I met Ana Carolina Barbosa, who is now a professor of forest science at Lavras University in Brazil. And she talked me into it. And it's been amazing. I've learned so much from this and trying to, let's see, close this. Yeah, sorry. And let me move that over. Thank you. So, uh, it has been an amazing experience because, as we all know, Amazonia is stupendous in terms of its biological richness. There's 5.5 million square kilometers of tropical rainforest in the Amazon, the largest tropical rainforest on Earth. Here is a photo I took some years ago at the cut front at the Belo Monte Dam site on the Rio Xingu, where Ana Carolina and I went and collected huge volumes of cross sections. I mean, from killed trees that were deforested because of this gigantic hydroelectric project, which is a sad thing in terms of the destruction of nature, but is an opportunity, of course, to try to salvage, some of the environmental information that might be contained in the growth rings of trees. So that's what we're looking at here. Amazonia, of course, is the most species-rich forest ecosystem in the world. The great book by E.O. Wilson, The Diversity of Life, notes that maybe about 1/3 of all species of life on Earth are found in the Amazon, which is responsible for maybe 10% of global net primary productivity. And even more amazing, there's maybe about 400 billion trees, okay, 10 centimeters in diameter at breast height, in the Amazon. 6,727 species of trees have been described taxonomically by science in the lowland Amazon. You can see the Cardoso publication in 2017 that provides that number. The Terstegi paper, the famous paper in Science 10 years ago or so, uses kind of meta-analysis of plot data to estimate that actually 6,727 is way low, and there may be as many as 16,000 species of trees native to Amazonia. I mean, and we know there's more yet to be found because new species are found all the time. So this is a spectacular place. It's incredibly complicated. However, in all of this diversity of species, there is a subset, maybe 227 or so species of trees that are widespread and account for about half of all the trees in the lowland Amazon. And this component of Amazonia is referred to as the hyperdominant species. And among them is Cedrela odorata, cedro, which many of us are now working on and does sometimes at least form annual rings that can be used to develop tree ring chronologies. So the Amazon River, here's a map from the World Wildlife Fund, based on the shuttle radar topography mission, and kind of imaging the drainage basin of the Amazon, the river being the largest on Earth, of course. It's spectacular. It is, not only the largest river on Earth, it is trying to get rid of this. Yeah. Hmm. Not only is it the largest river on Earth, sorry, I can't seem to go back in this setup, but let's see. It's greater than the combined discharge of the next six largest rivers on Earth, okay? Two of which are tributaries to the Amazon. I mean, it is a spectacular thing. It is, larger. It is 5 times larger in terms of discharge than the Ganges. It's 12 times larger in discharge than the Mississippi River, and it's 414 times larger in discharge than the Colorado River. And I mentioned the Colorado River because in the history of dendrohydrology, that's maybe one of the most famous applications of tree rings, starting with Chuck Stockton's work, and then Connie Woodhouse, of course, David Miko. They've done so much work on reconstructing stream flow in the Colorado River in the western United States, which is a very over appropriated water resource, highly contentious as to who owns the water and how much water is present. So I always preface my talks on the Amazon trying to compare the importance of the Amazon to some of the most important tree ring work that, has heretofore been done, using in terms of hydrology. So, uh, what we're talking about today are two problems. One problem, of course, in the Amazon are these recent hydroclimatic changes that have been observed. And we see here a time series of Amazon River level. And this is based both on uh, Amazon River level at Obidos, and those are the red time series after about 1960, and Amazon River levels at Rio Negro at Manaus. Of course, Obidos is downstream from Manaus. River level and discharge both are highly correlated between the two stations, around zero point 0.9. And so it is possible to use, so Obidos is shorter, Manaus is the longest record, and hydrologists have put them together into this seamless record of water levels. And so you can see the annual high stand and the annual low stand, the wet season and the dry season uh, at, in this long record. This is by far the most important hydroclimatic record available, based on direct observations in all of Amazonia. And the problem is lately we've seen this amplification in the seasonal discharge cycle in Amazon River level. So the maximum and minimum flows have become more extremes with deeper floods and more extreme droughts. And you can note these public emergency thresholds, the little dotted lines that are plotted below and above the time series at 15.8 meters above stage and 29 meters above stage. So below 15.8 meters is a public emergency drought and low stands on the Amazon. And above 29 meters, of course, is flood. And you can see that the exceedances of these emergency thresholds have become more common, in recent years. So these are extreme floods and extreme droughts. They are real. They are being suffered by society and they are impacting nature. And so this is a major question as to why this is happening. And there's several, famous hypotheses, of course. Deforestation has been proposed to account for these changes for over 40 years. Intensification of INSO and the Walker circulation has been observed and may be responsible. Of course, it has a dramatic impact on precipitation over Amazonia. Of course, anthropogenic climate change and natural climate variability. This is, after all, is only 120-year long record, and surely it does not represent the full range of natural variability in high stands and low stands that the Amazon River is capable of producing. So the second problem I'd like to talk about is the problem of the instrumental record and the exactly dated proxy record. Both are limited. So what we're seeing at top left are time series of wet season total precipitation at Manaus, recorded with rain gauges, and dry season total precipitation. You can see that, and they're plotted in millimeters from 1901 out to 2016 in this case. And you can see there's about an order of magnitude difference in the average wet season total compared to the average dry season total. But more importantly, you can also see that these time series are internally inhomogeneous. The variance structure, the mean and the variance both change over time in highly unrealistic ways. And this is probably associated with changes in the technology of precipitation measurement, in the protocols used, in the position of the gauges and so forth. These are all very common problems in the measurement of precipitation. And we believe that, this is one of the two longest direct measurements of precipitation that we have for the entire Amazon basin, Manaus, the Manaus gauge. And it is internally inhomogeneous. And so I'd say after about 1960 or 1980, everything's fine. But before that, it's subject to great uncertainty. And so this demands that we come up with alternatives. This is why we study tree rings, especially trees, that are sensitive to precipitation and can be exactly dated. And so that, of course, is those exactly dated tree ring chronologies are extremely scarce in the global tropics, as the map in the lower left shows. So this is a map from 2017. There have been additional chronologies submitted to the International Tree Ring Data Bank in the last 5 years or 8 years now. But you can see that tree rings and really dendrochronology is distinctly a mid-latitude phenomenon. It's annual rings are very rare in tree species from the tropics globally. And that's ironic because the global tropics are the most species-rich forests on Earth, and most species in the global tropics do not form annual rings. Now, some do, and of course, and that's what we're after, and so this is one of the great challenges, of, dendrochronology right now. In the middle latitudes, it is the winter dormant season that induces this, periodic rhythm of growth that we recognize as annual rings in many species. But in the tropics, there is no strong temperature seasonality typically. There can be precipitation seasonality, such as Manaus, and there can, in some cases, be the formation of annual rings. And the best species that we've found so far, as have others, is Cedrela odorata. And this is a photograph of Cedrela odorata and Daniela granata de Souza in the Paru State Forest in the eastern equatorial Amazon, which is a federally owned forest, managed for long rotation forestry. And it is here where Daniela and I have obtained the samples that we use and have used in these reconstructions of precipitation. And the beauty of the Cedrela from the Rio Paru are the rings. This is the best looking, tropical tree ring series I've ever seen. I've worked in the tropics a little bit in Kenya and Zimbabwe, South Africa, and Mexico with Jose Villanueva, and now in Brazil. And we've looked at a lot of tree rings and a lot of samples. And we've done this, with cross sections cut at lumber yards where trees are being suppressed and cut. This is again the Belo Monte project on the Rio Xingu. There's tens of thousands of trees that were felled, for this civil engineering project, and we cut hundreds of cross sections from these timbers and tried to make chronologies, and it's pretty tough. But at the Rio Paru, we found some excellent samples, again on cut logs that were found in a legal logging operation, supposedly long rotation forestry practiced here. And this is a polished transverse cross-sectional surface showing the annual rings arranged vertically in the image with the dots indicating the decades, 1950 out to 2010. And you can see this ring porous structure of Cedrela odorata is quite clear at the Rio Paru. This is not so good everywhere. I mean, Cedrela odorata works great in some places, and in other places, we've not been able to date it at all. But here, we've got a very well replicated tree ring chronology, and we've actually made two of them separated by about 10 kilometers only. And they are both highly correlated with each other, and they're both ring width is well correlated with precipitation. And so we've used that relationship between the Cedrela ring width chronology and rainfall during the wet season. So that's February through July in this case. Total wet season rainfall is very highly correlated with ring width chronology, and we've used it to reconstruct wet season precipitation totals from 1772 to 2016. And you can see that we explain 42% of the variance here. And so what's being plotted in the upper time series are the annual estimates. And also the extremes above and below the 90th and 10th percentile extremes. We could call them unusuals. I mean, they're only, they're 10% of the data each. But as we're going to see in a moment, some of these unusual 90th percentile and above tree ring estimates of wet season precipitation were indeed extremes in terms of the discharge of the Amazon River, as were some of the reconstructed droughts. We also plot the 30-year waveform on here. And down below, we see that, in fact, the variability in Cedrela, the variability in the Cedrela reconstruction of wet season precipitation is coherent with precipitation variability across the Americas. There's this amazing Pan-American precipitation covariability that's indicated with principal components analysis on the right-hand panel down below. That's the first principal component of October through March standardized precipitation index from 1950 to 2016. And you can see that there's this out of phase relationship between the tropical Americas and the extratropical Americas. And on the left, you can see a composite analysis of tree ring chronologies. This is the raw tree ring chronologies available in North America and in South America. And it shows the mean growth and the significance of mean growth for 21 cases of low growth extremes in the Eastern Amazon. So when we had low growth and drought in the Eastern Amazon, tree growth was above average in southwestern North America and parts of Patagonia and South America. A great Pan-American interaction, of climate and tree growth, driven principally by the El Nino Southern Oscillation. So I'm starting to run out of time a little bit here, but I'll try to, since we ran into it a little bit, I'll try to finish up in about 8 minutes. But so this is ring width. We could do even better with isotope geochemistry. And this is Lucas Pierre's dissertation research with Anna Carolina at Lavra. So recently, Lucas has measured the oxygen isotope concentration of selected subsample of tree ring data from our Rio Paru site and used that to reconstruct wet season rainfall, in the same region that we reconstructed wet season rainfall with ring width. This is Del 18 estimation of wet season rainfall, and you can see that it explains much more of the variance. Almost 2/3 of the variance is explained here. I mean, this is an amazing improvement in the strength of signal, and you can see the consequences of it down below. If you correlate this oxygen isotope reconstruction of precipitation from the Rio Paru with gridded precipitation across the Americas. The colored patterns are statistically significant, and you can see the strong positive correlation in the eastern Amazon and northeast Brazil, and the negative correlations in North and South America. And on the left, you can see the correlation with the Rio Paru oxygen isotope reconstruction of precipitation with the global sea level pressure field and with the global sea surface temperature field. And of course, precipitation at the Rio Paru reconstructed with oxygen isotopes is negatively correlated with sea surface temperatures in the equatorial Pacific. The signature of ENSO, in this case, La Nina conditions, favor way above average tree growth. This is exactly what you see in the instrumental data. So this is amazing. All the correlations are significant. This is the imprint of the Walker circulation seen in the sea level pressure data and the Hadley circulation, all of it orchestrated by the El Nino Southern Oscillation primarily. So quite astounding. Now, one thing to mention on these extremes, I'm going to show you some validation of these extremes in the historical record. And this was a project that Daniela and I undertook during COVID when we were kind of locked down and we had lots of time on our hands. And so we took our reconstruction and we went to the historical record to try to see if there could be any substantiation of the drought, for example, in 1865 or 1877, the floods, the heavy precipitation in these other years. And that's what I'm showing here. This is the forgotten drought of 1865. And what we've done, Daniela and I have, accessed the Brazilian Digital Library, which is keyword searchable. And we looked in the year 1865 for all references to drought. Now that's problematic because there's carne seca, and there's dried fruit, there's dried this, there's dried that, and drought. So we had to carefully scrutinize all of the keyword returns for unequivocal references to climate, not meat and not fruit. And so that was a laborious thing, but then we counted up the number of historical reports, and so we see here in 1865 the number of historical reports to drought or to wetness. Dry is red, wet is blue, and state level reports are with a cross, more than 20 reports with a circle, and then we categorized our two tree ring chronologies into percentile groups of increasingly dry and increasingly wet, and you can see our two chronologies are very dry in 1865. And then we look in the Diario so there's hundreds of reports being mapped here, right? And so one of them, the Diario de Pernambuco in January 24, 1865, the Vejante of 1864-65 was the lowest ever witnessed on the Rio Negro. The Diario de Rio de Janeiro in September 1865, the steamship Ikamiaba grounded twice on the September trip. And even more amazingly, Louis Agassiz and Silva Coutinho participated in the Thayer expedition into the central Amazon in 1865. Of course, Louis Agassiz was a professor at Harvard, very famous geologist and glaciologist, for which Glacial Lake Agassiz is named in Canada. And this is Silva Coutinho. He's the John Wesley Powell of Brazil, a great engineer and scientist and military officer. And they went together up the Amazon River in 1865 on this ichthyological expedition to study freshwater fishes. And they note the maximum ebb, this is from Coutinho, the maximum ebb here near Tabatingo, large banks of sand and mud are discovered on the headlands of the islands, even in the middle of the river, where inhabitants of villages are camped out to fish. So they discovered during this 1 year 800 new species of freshwater fish. That's amazing. So Carl Linnaeus, 100 years earlier, did not know there were not that many species of freshwater fish known in the entire world, to the great inventor of the Systema Naturalis, Linnaeus. So, but it was drought that facilitated this because the water was so low. The Amazon River itself was ponded in places and creating ideal conditions for collecting freshwater fish, like shooting fish in a barrel. This is an amazing independent validation of the lowest precipitation estimate that we find in our tree ring reconstruction of wet season precipitation, the year 1865. Then the last example, the Amazon flood of 1859. This is one of our wettest years. And so Epoca in June of 1859 notes, at Santarém, the Amazon flood covered all the lands and even was to harm some establishments built in lands of the mainland and very high. And its invasion went to towns like Santarém, where First Street was completely impassable, and now traffic can be made by canoe. I mean, amazing. So here's a potential datum for a high water level on the Amazon River in the pre-instrumental period, 1859. And so we went to Santarém and we measured, we hired a firm, engineering firm, to measure First Street. Okay, First Street is still there. It's got a different name, but we studied the history of it. It's the street is still there. And the lowest elevation that we find on the street is 10.2 meters above sea level. The record flood, this is the biggest flood ever on the Amazon River known, was in 2009 at Santarém. And, 2 millimeters greater, 10.22 meters above mean sea level. But so if this is the same elevation in 1859, which of course it might not be, but if it were, and you had to float a canoe, maybe you need a half a meter to float a canoe, maybe the elevation of the Amazon River in 1859 was 10.7 meters. I mean, that means that the Amazon, if this is right, of course it may not be, but if this is right, the Amazon flood of 1859 may have been the most extreme in the recorded history of the Amazon, exceeding even the recent extremes. It would make it a candidate for the largest known meteorological flood in world history. Why? Because the Amazon River mean discharge is 224,000 cubic meters per second. It dwarfs all other rivers. So the biggest flood on that river is certainly the biggest flood, in the world, the biggest meteorological flood in the world. I mean, there are ice dam collapse floods like Glacial Lake Missoula that were more massive. But in terms of meteorologically driven floods, 2009 is the current world record. And 1859, and for that matter, 1892, identified with tree rings and historical data, may have exceeded that. Anyway, this is amazingly interesting. We're just getting there. And lastly, we're working with the guys and the gals on the giant trees of the eastern equatorial Amazon. And here's a photo of Denisia excelsa. Many of them have been found that are more than 70 meters tall. And this is just upstream from where we've made our cedrela chronologies on the Rio Paru. And it's also found in the Rio Jari drainage basin. And currently, the record holder in the Amazon is an 85-meter tall Denisia excelsa. But there's also cedrela mixed in there. And Daniela, I didn't get to go, but Daniela's been in there and took increment cores from these giant trees. And we're building a chronology. It's much more difficult to do with increment cores than with cross sections, of course. But there is some cross dating thanks to the fact that we already have some cedrela chronologies downstream, and we are beginning to build a record. But it's a tough slog. Thank you very much for including me.
Thank you very much, dear Professor Dr. Stahle. So very interesting your contribution for the Enroll community. So if you have any question, you are welcome. Please. Very interesting your topic there, Professor. Especially I see your image about Cedrela odorata very clearly the terrain, very distinctive.
Yeah, no,
Like a perfect.
Yeah, no kidding. I mean, it's, I worked with Pterocarpus angolensis in Zimbabwe, which is pretty good when it's young. You can see the rings in Pterocarpus angolensis, on the edge of the Kalahari Desert, pretty well. But when they get old, boy, it's tough. And same is true for Cedrela. When Cedrela is suppressed, it is nearly impossible to image the rings and confidently date them. And we've found individual Cedrela that are over 300. And I think by simple ring count, this is by simple ring count. This hasn't been determined with dendrochronology. We even found one that has more than 400 rings, but they're so small, they're so suppressed, and they are so ill-defined anatomically that we can't date them. And so maybe in the future, possibly, and we don't, it's real hard to work in Amazonia, as you know, and it's difficult to go there. It's difficult to get samples. Increment cores really don't work, by themselves. Usually it's very difficult. And so this has been very slow to develop. But, I think as we make each new chronology, that makes the job easier because then we have time series with which we can compare. And the fact that there's this interaction, between the tropics and the extratropics in the Americas, it turns out that the Cedrela chronology from the Rio Paru is correlated with Mesa Verde Douglas fir. Okay, Mesa Verde Douglas fir is the type site for dendrochronology. This is where A.E. Douglas first developed dendrochronology as a science. Of course, he started in Flagstaff, but the Central Pueblo dating chronology, which is the first one ever made, which was used to ultimately date the Anasazi ruins of the American Southwest, was based on, Douglas fir and ponderosa pine. And they're correlated with Cedrela odorata in the tropics. Amazing. Certainly the extremes, and in terms of the oxygen isotopes, they're definitely correlated. And so now we have control. We have potential control on using the most confidently dated tree ring chronologies ever made, right? That would be the southwestern United States. So and we can thank the El Nino Southern Oscillation, for this, covariability of climate and tree growth across the equatorial and extratropical Americas.
So interesting there, Professor. The Professor Dr. Mahmouda Islam have one question. You're welcome there, Dr. Mahmouda.
Yeah, thank you, Professor Dr. Stahle. I really like your presentation, especially in Cedrela odorata, and I especially fond of your study, especially flood and Amazon is some study based on Amazon River. It's really interesting. But I have a not a question. It's like I have an interest to know how you detect the flood rings or how can we determine, how can we measure the flood rings or identify the flood rings in any species?
Okay. Are you still seeing my screen, Kelly? Are you
Yes.
still, you see my screen?
Uh,
No,
we are
only see your
No.
face, not
a lot.
screen.
Okay, well, I can just tell you, no big deal. We don't have flood rings. We have the tree ring width chronology, which is ring width from 50 radii, and we make the time series. And then we looked at the years of largest growth of, you know, fat rings and the
Okay,
years of poor growth, skinny rings. And we
okay,
compared them with, we actually reconstructed wet season precipitation first from the time series, but that it would work either way with the original chronology or with the reconstruction of wet season precipitation totals. And we simply looked at, hey, what's the wettest years in our tree ring reconstruction? And then we went to the Brazilian Digital Library, which has 13 million references, okay, documents, letters, reports that
yeah,
can be searched. And what we were doing was using the historical record to examine, are the tree rings accurate? When they say it was a wet year, was it really wet in the 19th century before any kind of instrumental observations of precipitation or stream flow? And yes, 1859, 1892, 1897 were incredibly wet. In fact, 1859 may have been, the Amazon River may have reached its largest level. And
okay,
then for drought, we know that 1877 was a gigantic El Nino event that causes drought in the Amazon and low flow on the Amazon River. And that's one of our lowest values in the tree ring reconstruction. And 1865 is the lowest value. And then we find all this information about both years. Yeah, it was a terrible drought. It was called the Forgotten Drought of 1865 because the drought certainly occurred, but cotton prices were inflated because of the American Civil War and the collapse of cotton production on the slave plantations of the Old South. Such a heinous activity. But this is why we fought the Civil War. And so prices for cotton were incredibly high. And so cotton somewhat drought resistant, and growers in Brazil were able to sell their cotton produce at a very high value. And so the socioeconomic impact of the drought of 1865 was not so great. And that's why historians refer to the drought of 1865 as a forgotten drought. And yet it did occur, and it may have been one of the lowest levels in the historical era on the Amazon River. So it's a comparison of the proxy record with the historical record.
thank you so much. Yeah.
Thank you so much, dear Professor Mahmoud, for your question. And maybe another participant, would you like to make a question? You are welcome. We have time.